Finding rational roots. What this is really related to is that we just got done last unit solving by factoring and figuring out how to get all the possible roots that way. Well, there's got to be a different way because some polynomials, or not all polynomials, are factorable, nor will they cross the x-axis. So here's a little bit about it. We have the rational roots there, and rational roots just basically means fraction or whole numbered possible answers. First, you got to make sure that your polynomial is in standard form. Okay, so let me get a marker here. So make sure it goes in standard form. It is the factors of the first term, so I should say that factors of the last term, so in this case 4, over the factors of the leading coefficient, which basically is the first term. So by factors, I have 1 and 4 multiplied together to give me positive 4. Well, I have a positive and a negative each of these, because negative 1 times negative 4 can also give me positive 4. And then I got plus or minus 2. Now, I could write that twice, 2 and 2, but it doesn't really make any sense. It's kind of redundant. And on the bottom I've got plus or minus 1 and plus or minus 2. Those are my factors of 2. So I'm going to go through and I'm going to divide all the top numbers by plus or minus 1, and none of those are going to change. So plus or minus 1, plus or minus 2, plus or minus 4. Now I'm going to go through and divide them all by 1, and I get plus or minus 1 over 2, 1/2. 2 divided by 2 is 1, but it's already on my list, so I don't need to write it again. And 4 divided by 2 is 2, so it's already on my list. So here is a list of 8 possible rational roots. That doesn't necessarily mean they are rational roots, but it's my possible rational roots. Okay, so here, list the possible rational roots. Again, we got to have it in standard form. Here's my 1. It's really nice when the leading coefficient is 1, because now it's the factors of 9 over the factors of 1. So plus or minus 1, plus or minus 9, and plus or minus 3, all over plus or minus 1. So there's basically my list that way. There is no other factor for 1. I don't have to go through and divide them all by 2 like I did the previous one. Okay, now the fundamental theorem, and I gave this one away to you guys long time ago, is that for any function of a polynomial with nth degree, so this is a second degree, that means I'm going to have 2 roots. Now, here's a 5th degree, that means I'm going to have 5 roots. That doesn't necessarily mean that they're all real roots or they're on the x-axis. That just means that I'm going to have that many roots. So I'm going to put this kind of all together. I'm going to go through and list my possible rational roots. So it's the factors of 15 over the factors of 1. So plus or minus 1. And plus or minus 3, plus or minus 5. Okay, I'm going to give you a graphing calculator, or you're going to go onto Desmos and you're going to type in that function. You're going to see where it crosses the x-axis, and I notice it crosses the x-axis right there, so I'm going to say x is equal to negative 3. Well, that is one of my possible rational roots. So this list, along with this graph, helps me decide that x is going to possibly be one of my answers. How do I know for sure? I'm going to put negative 3 in and use synthetic division. So let's see, go through there, drop, mama, so multiply, add, multiply, add, multiply, add. And since I get 0, that means that that answer is a root. So x is equal to a negative 3 is one of my 3 roots. And again, I know there's 3 roots because of that cubic. Well, synthetic division leaves me with this quadratic of 1x to the second power minus 2x plus 5. And I could try to solve that by factoring, or I could try to solve that by the quadratic formula. So the opposite of negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 5 all over 2 times 1. So 2 plus or minus, and that's going to give me 4 minus 20, so negative 16. Okay, so 2 plus or minus 4i over 2. I can divide all those by 2, so I got 1 plus or minus 2i. Now, that makes sense. My graph only crossed the x-axis once. That's my real answer right here. Here are my other two answers that were imaginary. Oh, and by the way, imaginary numbers or complex numbers always work as conjugates. Basically, they always come in pairs. And the only real way I have to find my imaginary roots would be the quadratic formula. And where the two answers come from is the fact that I got a plus or minus in the quadratic formula. Or if I'm solving by the square root, I can get a square root of some negative number and get plus or minus that number as well. Okay, so that's kind of information that helps out a little bit later. Okay, so I have my possible rational roots. So plus or minus 1, plus or minus 2, plus or minus 4. Now I got plus or minus 1, and I also have plus or minus 2. So I've got the top ones by dividing by 1. I'm going to divide by 2 now, and I got to add plus or minus the 1/2 on there as well. The rest of those are already on there, so I don't have to worry about relisting those. But I've got 2x to the 4th plus 3x to the 3rd minus 6x to the 2nd minus 6x plus 4. And I'm going to leave here for a second, and I'm going to go to Desmos. Okay, and go 2x to the 4th plus 3x to the 3rd minus 6, oops, I don't want a subscript there, I want a superscript, x to the 3rd, okay, minus 6x squared minus 6x plus 4. Now, oops, I must have typed in something a little wrong here. 2x to the 4th plus 3x to the 3rd minus 6x to the 2nd minus 6x plus 4. I'm going to go back to my function here. Oh, I got an extra term in there. No, I don't. So 2x to the 4th, 3x to the 3rd minus 6x squared minus 6x plus 4. 2x to the 4th, 3x to the 3rd minus 6x squared minus 6. And I gotta Oh, 14. Shoot, undo. That's a big problem. What I'm looking at there is I got a 14 and it never crossed the x-axis. It kind of needs to. So there we go. I got my graph here. I'm going to look to see where it crosses the x-axis. So what's nice about Desmos is I can actually click on that guy right there, and it shows that -2 is one of my possible answers. So I got my graph. It's already done. I used Desmos for that. Now that I think that -2 is one of my possible answers, I got 2, 3, -6, -6, and 4. Drop mama. Hey, and now I've got a cubic. 2x to the 3rd minus x to the 2nd minus 4x plus 2. So I'm going to go and I'm going to take and put that in to Desmos. So I'll pull up Desmos. I know I can split the screens, but guys, I'm not that good yet. So I'm just going to go through here, take out that original one, and I've got 2x to the 3rd minus x squared minus 4x plus 2. And I'm going to see where it crosses. Looks like negative, I don't know, on that one, maybe at 0, or maybe at, I got to get a little bit better at typing. I need a plus 2. Okay, so there, it looks like 1/2 is a possibility. So now I know it's not a popular choice, but I'm going to take the 1/2 and put that in synthetically. There, half of 2. 1, 0. Multiply that, I get 0, -4. Half of -4 is -2. There we go. And I'm left with a quadratic of 2x squared, no x's, and -4. Now, I don't even need the quadratic formula for that. I'll just solve that by taking and solving a square root. So 2x to the second equals 4. Divide by 2, x squared is equal to 2. And my answers are going to go up here. Our x is equal to plus or minus the square root of 2. -2 worked, and 1/2. There's my 4 answers. And if I go back to my original graph, that did have 4 x-intercepts. There's just no way I would have guessed the square root of 2's decimal. Okay, so here's kind of the process again. You don't have a quadratic yet, so you need to repeat the process. So I did. I took my cubic, I graphed that. I did synthetic division. I found out that 1/2 was one of my answers. When I finally get to a quadratic, I need to use either the quadratic formula, factoring, square roots, or any other method to find those 2 roots. So the idea is to graph synthetic division, until you finally get down to a quadratic, because quadratics, we have multiple methods to solve.